I'm Anil Kumar. Welcome to my series on linear differential equations. This is the very first video which you should be watching to understand this topic. We'll actually first understand what are first order linear differential equations. So the example here you could see is we need to just figure out which one of these is a linear differential equation and which one is not and why it is so, right? Second, we'll try to understand what are separable differential equations, which we know, right? So we'll try to figure out why they are not separable and therefore they have a solution which is slightly more difficult than which was adopted to solve differential equations which were separable, right? So we'll look into that part. And then we'll provide you with a general solution of a first order linear differential equation. And then we'll have an example. So I hope with this you can get started with this topic on linear differential equations. Now, what are linear differential equations? A first order linear differential equation is one that can be written in the form dy dx plus p of x times y equals to q of x, where p and q are continuous functions on a given interval. That is important definition, right? So basically, if you could write any differential equation in this particular form, then it is a linear differential equation and that can be solved by the method which we'll learn in this particular video, right? Now, let's get straight to the question, which is determine whether the differential equation is linear or not. So we have three examples. So basically, we need to write them in that form, that is y dash plus some function of x times y equals to another function of x, right? These could be constant also. Perfect. So if you look into the very first one, which is given to you as cos square x y dash plus y equals to tan x, I could actually isolate y dash by dividing cos square x, right? So if I divide, I get y dash plus 1 over cos square x y equals to tan x over cos square x, correct? So I have written it in the given form, and if you compare, you could easily say that in this case p of x is equal to 1 over cos square x, or you can say secant square x, and q of x is equal to tan x over cos square x, right? So that is how you could identify p of x and q of x. Soon you will learn why it is very important to identify these, since p of x and q of x will be part of our solution to the differential equation. Perfect. So that's why it's a very important exercise. Now let's look into the second one, which is x y dash plus ln x minus x square y equals to 0. So let's try to isolate y dash now, the way we did, like we'll write like this. So we'll divide everything by x. So what we have here is, we could write this as y dash plus ln x over x minus x square y over x equals to 0. So we want the terms here which have y dash and y. The other terms should move to the right side. So we could rewrite this as y dash minus x times y equals to. So this plus goes to this side, becomes negative, right? So it becomes negative ln x over x. Do you see that part? So this equation again is a linear differential equation, right? So this one is a linear differential equation. This is also a linear equation, right? Here, what is the value of p of x and q of x? Let's write it down, right? So as I said, it's a very important part of our solution. So in this particular case, we get p of x as equal to minus x and q of x is equal to minus ln x over x. Correct? So it is a first order linear differential equation. Now how about C? Now in C, what you notice here is that we have the term y square. Right? So that means it is not. Correct? So So that is the first thing you notice, and straight away you can say that it is not. So from here I can actually add a note to our understanding how to identify, right? So the dependent variable, that is this y dash. So the dependent variable and its derivative should be of order 1. Is that clear? So by inspection, you could actually immediately say that this is not a first order linear differential equation, since we have a term y square in it. Perfect. So that is what we could actually do. Now, second important thing is, we have been talking about this equation. We're talking about this particular equation, and we have already learned another equation which is kind of separable, right? So we'll now see how to identify whether the equation is separable or not, right? So note here that these equations are not separable. Right, so I'm specifically writing they're not separable when we are treating first order linear differential equations, right? Since we'll follow a method to solve them. If they are separable, you have an easier method to solve. Perfect. Okay, so let's move on and take the second question. Now we are going to take a minute to understand what are separable equations, right? A separable equation is a first order differential equation in which the expression of y dash can be explicitly written as a product of function of x and function of y. That is, dy dx equals to g of x times f of y. So those are the separable equations which we solved, right? So the one which we're talking about are not separable, and so we have a very special way of solving them. Question for you is, determine whether the differential equation is separable. So we are given two equations. You have to figure out if they are separable or not. So let's work on this. So separable means you could write dy dx in the product of that form, correct? So y dash we can isolate. So we could say y dash is equal to taking 6x squared to this side and then dividing by 2y plus cos y, correct? So that means these are separable, right? So this is definitely separable. Now why it is important to identify? Because if you know it is separable, you have a very easy way of solving. Let's solve this. Dy dx is equals to 6x squared over 2y plus cos y. So if you cross multiply, you get 2y plus cos y times dy equals to 6x squared dx, right? Now we could integrate both the sides, right? So if you integrate, since you have isolated them, right? So now if you integrate, you get what? So you get 2y squared over 2, which is y squared, and this is plus cos sine y, and here you get x cubed divided by 3, so you get 2 here, right? Plus c. So that becomes the solution for you, correct? So it could be easily solved. Right? It is a separable equation. Now let's look into the first equation. Now here you cannot write y dash as product of g of x and f of y, correct? So it is not separable. So this one is not separable. So this one is not separable. Of what form it is? Well, it is in the form of linear differential equation. You could isolate y dash, right? So you say y dash. I'm not saying isolate means divide by x, right? So when you divide by x, you get 1 over x times y equals to, taking it on this side, equals to 2. So you get this as a differential equation, right? Linear differential equation, where we know now p of x is 1 over x and q of x is equal to 2. So that is the type of linear equation which we are going to solve in this particular video. So I hope that concept is clear. Okay. Now let's move on and take this equation to solve. Now let's continue. We will now understand the concept to solve the first order differential equation, which are of the form dy dx plus pxy equals to qx. The example is, xy dash plus y minus 2x equals to 0. We just saw that it is not separable. However, we could write it in the given form. So the equation here is xy dash plus y. We can take 2x to the other side, right? So kind of like this. Now, if I want to write like this, then becomes y dash plus dividing by x, I get 1 over x times y equals to 2. Right. So that becomes the equation in the given form. So this is definitely a linear differential equation. How do we solve this? Now what you also notice here is that if you look at this equation, we have the term here which is x y dash plus y. Now does that remind you of something, right? So we have x y dash plus y. Now this is equal to x y dash, derivative, product rule, right? So that reminds us of product rule. Perfect. So what we notice here is that in this particular equation, if I am given a linear differential equation, which is right here, this is our linear differential equation, correct? So in this linear differential equation, what we notice is that if I multiply by x, I get something which is xy dash, and now I can integrate, right? Correct? So that is what it is. So what we could rewrite the equation from here as the left side x y dash plus y could be written as xy dash equals to 2x. Now we could integrate both sides and get the solution, right? So now we could do xy dash equals to 2x, right? So if you integrate both sides, then what happens? If you integrate both sides, let's write down. Then what we get here is xy equals to x squared divided by 2, and this is 2, so we get x squared plus c. Correct? So we get our solution. And we can isolate y and then write down y as equals to x plus another constant, c over x you could write, right? Plus another constant. Anyway, so you could write this y as x plus c over x. So that becomes the solution for us. So there is a way to solve such equations, correct? So what you notice here is that we multiplied starting from here. What you notice here is that if we multiply by a factor which was, let me highlight this because that is key for our understanding. If we multiply the equation by a factor, in that case it becomes in a form that it could be solved, right? So this factor, which is the multiplication factor, is called the integrating factor. So we multiplied by 1 over x in this case, right? So this factor is the integrating factor. Which helped us to write the equation in a form that could be integrated, right? So in this particular case, we saw it was 1 over x, right? So what do we note here is that all linear differential equations can be solved, can be possibly solved, right? By using integrating factor. Right? So it is a function of x. We'll normally write this as I of x. Is it okay? So that is our integrating factor. At times, I'll also write this as I dot f integrating factor. Perfect? So either thing which we are going to use. So now the idea here is to take up a general example, which is the given equation, and see how do we find an integrating factor to solve any linear differential equation, right? So let's get to a general solution. Perfect. Now let us try to understand the general solution for our linear differential equation y dash plus pxy equals to q of x. Now to find a general solution, we need to figure out what is an integration factor I of x by which we can multiply both sides, right? So the first step is we need to find what is I of x, right? So I of x will multiply the whole equation. So what we get here is y dash plus p of x y equals to I of x times q of x, right? So we need to find what I of x is. And what is the property of I of x? The property of I of x should be that if you multiply this, then so the property of I of x is that the left side, which is given to us as I of x times y dash plus p of x y, should be equal to the derivative of product of integrating factor and y. Right, so that is the condition. That is how you have to find the integrating factor. Is that clear to you? Right? So that is key to us, right? Now let's try to understand this particular equation itself. So if I expand this, what do I get? If I expand this equation, I get I of x times y dash plus I of x p of x y equals to, applying the product rule here, we get I of x dash y plus I of x y dash, correct? Now as you can see from here, the two terms ix y dash, they cancel away, correct? So you're left with I of x p of x y equals to I dash of x y, correct? So that is what is remaining. Now well, let's cancel y also, correct? So what remains is a separable form. So this is a separable form, right? So we are left with a separable form, which is I of x p of x equals to I dash of x, right? The derivative of I of x. Now this could be integrated, right? So now we could do integration of di over I is equal to integral of p of x dx. Now this integral is ln I, right? The absolute value of I. And so we have an integral of the function p of x dx. So here we have a solution, correct? And from here we can actually figure out what this integrating factor is. So the integrating factor I could be written as a times e to the power of all this, which is integral of p of x d of x, right? So for normal calculations, we take a as equal to 1. So here we get a very important conclusion, and that is that I, the integrating factor, is equal to e to the power of integral of p of x dx. So that becomes our integrating factor, which could help us solve this equation, provided we multiply by this on both the sides, correct? So if we multiply this on both the sides, then we could solve it. Now how to solve? Let's look into that portion also, right? So we are saying when you multiply, this left side actually becomes what this is, which is I of x times y derivative, right? So this is equal to I of x times q of x. Now if you integrate, both sides, what do you get? You get the integration factor times y is equal to the integral of integration factor times q of x, right? Dx plus c. So that is what you get. Perfect. So when you know this integration factor, then it is very easy to find the solution. Correct? So general solution will be this y is equal to 1 over integration factor times integral of integration factor product with the right side, q of x dx plus c, right? So that becomes your general solution, right? So this becomes your general solution. You get an idea, right? So that is how you could actually get a solution, correct? Now, what you really need to remember to solve linear differential equation is the integration factor. So what you need to remember is this, that the integration factor I is equal to e to the power of integral of p of x times, p of x d of x, right? And once you do that, once you find this integration factor, in that case, you could actually multiply your equation and write it in this form. Integration factor times y is equal to integral of integration factor dot q of x, right? So now you understand the importance of finding p of x and q of x to get the solution, right? So the first step here will be, this is your first step. Find integration factor. Is it okay? That is your first step. And that could be found by e to the power of integral of px dx. Once you find that, then you straight away write your equation in this form. That is the product of integration factor by y is equal to integral of integration factor times q of x dx plus c. Do you get an idea? So that is how you actually can solve any differential equation of first order, right? Let's take up an example to illustrate. Now let's try to solve a differential equation from the strategy we have learned. Question number 3. Solve differential equation dy dx plus 3x square y equals to 6x square. Now this equation is in the form of, let me write down, dy dx plus p of x times y equals to q of x, right? So if you compare, you know what p of x is. P of x is 3x square. And q of x is 6x square, right? Now from here, you can find the integrating factor. What is that? Integrating factor is e to the power of integral of p of x, right? That is what it is. So in our case, p of x is 3x square. So we could write this as equal to e to the power of integral of 3x square dx, right? Which is e to the power of, that is x cube, right? So we get e to the power of x cube as our integrating factor. Correct? Now once you have the integrating factor, you need to multiply all the terms with the integrating factor. Correct? So the next step is, so first step is, this is step 1. Find integrating factor I of x, or sometimes we'll be writing integrating factor like this. Is it okay? Now what is the step 2? Now step 2 is, when you times the equation by integrating factor, you get the derivative of product, right? So step 2 is to write it in the form of derivative of product, right? So we'll go in steps. So now when you multiply each and every term by e to the power of x cube, the first term, which is dy dx, plus e to the power of x cube, the second term, which is 3x squared y, should be equal to e to the power of x cube times 6x squared, right? Now what you notice here is that the left side could be written as derivative of e to the power of x cube, which is the integrating factor, times y derivative, d dx of this, correct? That is very important. So let's write it in this nomenclature. D dx of this is equals to e to the power of x cube times 6x squared, right? So that's what we are saying. So what you notice here is that the left side is integrating factor times y derivative. That is your left side, left hand side. So that is the whole idea of getting the integrating factor, right? Now you can easily integrate, since we have a form which is separable. Since it is separable, you can easily integrate and get your answer, right? So when you integrate, what do you get? You get e to the power of x cube times y as equal to integral of q we get here is 6x squared times e to the power of x cube dx, right? Which could be written as equal to e to the power of x cube to e to the power of x cube plus c, right? So we get our integral, and from here we can write what y is equal to. So y is equal to 2 plus some constant c over e to the power of x cube, right? So that becomes our answer, correct? So that is how you could actually solve this differential equation. Is that clear to you, right? So basically, once you find what integration factor is, you know that the derivative of product rule could be applied on the left side, and the equation could be written in the separable form, and then you could solve it. So I hope the steps are clear. Let's take one more example to end up this video. Now here is another example. Let us solve differential equation dy dx minus y over x equals to 2x squared. Now in this particular case, you need to compare your equation with the form dy dx plus p of x times y equals to q of x, right? So that is what you, so first thing is, what is p of x? So p of x for us is minus 1 over x, correct? And q of x is equal to 2x squared. So from p of x, we get our integrating factor, I of x, right? So integrating factor is e to the power of integral of minus, that is p of x, let's write general equation here, and then we'll write down. So the integrating factor, I of x, is equal to e to the power of integral of minus 1 over x dx, correct? Now, which is equal to integral of this is ln x, right? So we get e to the power of minus ln x, or it is equals to e to the power of ln x to the power of minus 1, or 1 over x, x to the power of minus 1. So the integrating factor for us is 1 over x. So that is the first step, right? This is our first step. Next step is we should multiply by the integrating factor all the terms, correct? So what we get here is, let's do it like this. So we get 1 over x times dy dx minus 1 over, this becomes x squared y equals to 2x, right? So that's what it becomes. Now the left hand side could be written as the derivative of the multiplication factor integrating factor, and y. So do you notice this part? So this is always a derivative of the product rule, right? So equals to 2x. Now this is a separable form. So now you can integrate and get the answer. Right? So that is your second step, correct? So now when you integrate both the sides, you get y over x as equal to integral of 2x dx, correct? That is what you get. And now when you integrate, you get y over x is equal to x square plus c. Perfect. So from here you can write what y is. So y is equal to x cube plus cx. So that becomes your required solution. So I hope the steps are absolutely clear, right? So step 1 for you is to find the integration factor, right? So that is first step. And step 2, this is step number 1. And then step number 2 is to write it in this form. That is to say, we could write this as integration factor times y derivative is equal to integration factor times q of x. Perfect. So once you get this, this is your separable form. And then you integrate to solve. So that is the strategy to solve any first order linear differential equation. Is that clear? Feel free to write your comment, share your views. If you like and subscribe to my videos, that would be great. Thanks for watching and all the best.